Hello everyone. So today we are going to solve 12th of August problem from the Gigs for Gigs. That is adventure in a maze. What this problem is saying is we have a 2D grid that is n cross n, and we have to start from the initial cell that is 0 comma 0, that is top left, and we have to go to the bottom right cell that is n minus 1 comma n minus 1, and we need to we have given some several conditions like how we can move. Grid can only contain three values, that is one, two, or three. If one is there, then you can move right. If two is there, you can move down. Or if three is there, you can move either right or down, or both directions are available. So we need to find out two things here, like what are the total paths that we can take from 0, 0 to n minus 1, n minus 1, and what is the maximum sum that we can achieve from like all of the paths. So these two things we need to find out. This is a very general problem, I would say, but the important point that we need to understand is how we can optimize this problem. So let's see over the whiteboard how it will look like. Consider we have given this example. Okay, and we have given the matrix is that is 3, that is 2, that is 1, and that is 3. So as you can see, this is the top left cell, that is 0, 1, 0, and 1. These are the indexes. So these are 0, 0, and we have to this path. How many can path can be possible? If we can start from here, if the value is 3, we can move right and down, right? So we can move here or we can move here. We have both the conditions. So let's suppose if I'm starting 3, I can move to 2, or I can starting from 3, then I can move to 1, like in the down direction. If I'm coming to 2, then how where I can go? If the value is 2, then I can move down only. So I can move down, so that will be 3. I will get the value as 3. If I'm 1 is there, so I can move right, so I will get the value again as 3. So there can be two possible paths, as you can see, 3 to 3 and 3 1 3. Sum for this is 8. Sum for this is 7. So maximum sum that we achieved it, that is 8. So our answer will be 2 comma 8, because two paths are there and 8 is the maximum sum that we achieved. Okay, how we can solve this problem? As I explained, if the value is 3, then I can move out and right and down. If the value is 1, then I can move right. If 2 is the value is that, then I can move down. So simply I can write that same program in my code, like based on those values, and I am going to find out. Uh, I'm suggesting you, if you're a beginner, like try to write the brute force code, because whatever you are think, like whatever the problem statement is saying, these are very easy problems to going into the brute force. You can write that brute force code, then you can go for the optimization. We will see like how we can optimize this code. But in the first place, that I got this problem approach, and I'm going to write the same thing in the code. Okay. So I'm going to use the code in the breadth first BFS approach using Q, but you can try using DFS also. We have to do nothing. It's just we can make a recursion stack. We can store the initial value as 0 comma 0, and initial sum we can store that is 0, and we will see, okay, 0 0 it is there. So what it is storing is, it is storing your uh, index, that is row index. I'm storing first row index, column index, and what is the sum that I am achieved till now. So these three values I'm storing in the recursion stack. And if you take this value out, you can see from 0 0 where I can go. I can go 0 comma 1 and 1 comma 0. So similarly, you can go to like 0 comma 1, and again the sum will be like 3, because 3 we have took from 0 comma 0. And similarly, I can go to 1 comma 0, and some that is same as 3. Again from 0 comma 1, where I can go 1 comma 3, sorry, 1 comma 1. So that I will do 1 comma 1, and sum I have achieved till now is 5, because 3 plus 2, that is 5. And what is the next is 103. So 103, I can go to 1 comma 1. Again, I am writing here. So 1 comma 1, and sum I achieved is 3 plus 1, that is 4. So this is achieved. From 1 comma 1, where I can go. So 1 comma 1, when I encountered it, means I am reached the bottom right cell. So I will not do anything. Let's suppose I have a variable that is counted as a path. So initial that is 0. If I encountered 1 comma 1, it means I encountered one path. I will increment the value, and I will see what is the grid value of this value, this n minus 1, n minus 1, that is 3. So my sum will become as, till now my maximum sum I encountered at 0. But as I encountered this variable, so I can say my maximum sum become 8. And now I will not going further, right? I'm reached the bound. I reached the destination cell, so I will not go further. There is no meaning of to adding further details into that. And if you see, we will also outbound the matrix from here. Checking for this 1 comma 1 comma 4, again I reach the destination cell, so my path will increment the 2, and my sum till now it is 4. 4 plus 3 grid sum, that is 7. So 7 is not greater than 8, so my maximum sum still remains same. So simply we have seen like max path I found out and maximum sum I found out, and I just simply return it. So let's move to the code. I wrote the code in Java, but similarly you can follow in your preferred language. What I'm doing is I created a one queue that is same like index row, index column, and the current sum that I've achieved, and path and maximum variable. I'm going to do initially, I have added this path, this initial value, that is top left, and for each of the value that I'm taking it out from the queue, I'm checking like I'm reached the destination cell. If I'm reached there, so I will just incrementing the path, and I'm taking the maximum sum that I've achieved till now. And if I'm not reached, so I am checking like if the value that I'm getting it as a grid value, that is 1. So if it is 1, so I can move right only. So I will move to the right only. And now you can understood if I am a I comma j, if I'm moving the right, then my variable will become I comma j plus 1, uh, like uh, this one. And if I'm moving down, then it will become I plus 1 and j. So these are the values directly I'm telling us. If it is right, then I'm just incrementing the column value by 1 and current sum value by 1. Why current sum value by 1? Because our grid value is 1. You can also tell like grid or C row, C column that you can add, but I'm just directly adding the values, hard coding it. And if you are going down, then again I'm checking like if the grid value is 2, it means we can move down. If we are moving down, then I'm adding again the value into the queue. If the value is 3, then it means we can move right or down both. And in that case, I'm just taking like if down is possible, then I'm moving down also. If right is possible, then I'm moving right also. And after all, when the queue going to be empty, then we are going to return the result of the as a path and maximum that we have achieved. So as you can see in this problem, okay, so first of all, like I can try run this. So it is working fine. But the point is, what is the time and space complexity for this program? So if you see, time complexity will be like for every value we are adding into the RQ, and we will check if it is possible or not. And for every path that we are going to iterate, we are going to iterate. Consider a matrix, sample matrix that is 3, 3, 3. Every value is 3. So for every, what will my code do? Like for every element, it is going right and down. It is going right and down. So for every element, there will be two choices. So it is an exponential code that is going in multiple times, and it is going to find out like for each and every time what we are going to do. So of course it is exponential code that we cannot go further, and so we have to optimize it. As you so if we think from the optimization purpose, like what we can do is just let me erase this. Okay. So what we can do is consider we have this same example that is 3 or 2, that is 1 and 3. What we are doing is like we are iterating every path, like okay, we can go from 3 to 2, 3 to 1, 1 to 3, 2 to 3, and let's suppose the other variables are also there, so we are going to every path. To reduce that thing, only we can optimize here, right? We cannot do any other optimization that I cannot see. The only optimization that is like we can pre-compute the values. Okay, like pre-computing I mean to say, like let's suppose this, consider this element anywhere in the matrix. If you find out like how many ways you can reach till here, with what is the maximum sum till you can reach here, you can easily find out the below cell variable, right? Consider I have some this type of matrix. There I have one, some variables, any variable, 1, 2, 3, anything is there. I'm trying to explain the approach, guys, like what can be the possible values. So consider I am here. What I need to, what I, how I can reach here. First of all, like I can reach from, uh, like from here, from this direction or from this direction. There is no other possibility that I can reach here, right? I cannot move diagonal. I cannot move here. I cannot come from here anywhere. Like I can come from only these two directions. And if I need to move to down, so what can be the possible values? So for down values, I can either have the 2 or 3. So it means this value should be 2 or 3. And if I need to move to right, what possible values that I have, that is 1 or 3. Because in 1, I am also moving right, and in 3, I am also moving right. And same for 2 or 3. There is, if like consider, if above value is not 2 or 3, it is 1. So I cannot move down, right? There is no point to reach here. I cannot reach here, right? And same for, like, consider this value is 1 and this value is 2. So I cannot, there is no possibility I can reach here. But in my current solution, I am adding this as also a possible solution, and I'm going from further here. What can be the possible solutions further it can give me? But the first of all, I cannot reach here, so there is no meaning to going further, right? So what I'm going to do is to optimization is I will consider, like, I can create like two matrices. That is, first I will store the what are the ways that I can move here, and the second is what is the maximum sum that I'm obtaining with them. So okay, what I'm going to do is I'm just simply saying, like, consider this again. I'm not bother about what are the values of these. Like, I'm just like, what can be the approach, how we can optimize this. I'm focusing on that. So consider, I am here at the value is 1, and here the value is, like, consider 3. So what are the possible ways? Like, consider you have find out the possible ways for reaching to till here, and possible ways to reaching till here. So again, like, if the value is 1, you cannot move down. So there is no way that it will contribute to this particular element. If the 3 is there, it can contribute to ways for this element. And we can say, like, whatever the ways till we reached here, plus the one, we can say, like, we can reach like this is the same value, right? So this is the same value that we can achieve. And consider if I'm coming from here also, like, consider the value is 2 here, and I can came here from also. So ways for this to reach till here is ways of this plus ways of this, right? So I mean to say is how I can reach, that is the main important part. Where I can reach, and what is the maximum value that we can reach. So consider for the maximum sum again. What we are going to do is, so again, like, same problem. Like, if 2 or 3 is there, it means I can move down. And if I'm moving down, I will see, okay, what is the maximum sum that I obtained till here, and what is the maximum sum obtained till here. And I will do what I can do is I will check if I can reachable till if I can reach here from these two. Then I will check what is the maximum sum that I can obtain from both of them. Whatever the maximum sum that I can obtain plus grid of this, whatever the value that it is obtaining. So this will be maximum sum to reaching here with the number of possible paths that I can find out. And this will be the after fulfilling the matrix, we can easily find out in big O of 1, like, by just calling the giving the indices to the matrix, and we can get it, like, what are the maximum, what are the ways that we can obtain to reach any particular index with the what will the maximum sum. So this is a simple logic. Let's move to the code, like, how we will see to. It's a very easy code. Like, what I've done is I'm just taking, like, -1, that is the max. This cell is unreachable. I'm fulfilling the matrix, like, maximum sum with complete -1. So initially everyone is unreachable, and I will see, like, whenever we are going to reachable, I will increment the sum, or otherwise it will be -1 only. Starting for the starting cell, like, top left will be the ways to reach there is 1, and maximum sum again it is the, like, grid of that value, whatever the value is. So I'm checking first the first column. What will the value of the first column? So for first column, if the previous cell is not reachable, like, there is no meaning to reach here, right? If the previous cell is itself is not reachable, I cannot reach this index, right? So again, if the previous cell should be reachable, and the previous cell value should not be equal to 1. If that value is not equal to 1, it means the value will be 2 or 3. And if 2 or 3 values there, then I can say, then the like, I can move to the like, down. So basically, I will allow to move to the down. And I can say, like, just I'm taking the ways that that the previous element have, and the maximum sum I am adding as of with the grid value that I've explained in the whiteboard. Same for the first row. Like, I'm just doing the same computation. I'm just checking, like, the previous cell it is reachable or not. If it is reachable, Then I'm checking like the value of the grid, because value of the grid is also matters here. Like what is the value of the grid, that can I move to right, or it is allowing me to move right or not. If it is allowing to move me right, then I will check the base and maximum sum again. But for the remaining cells, like we just covered first row and first column, the remaining matrix, we are simply doing in the same manner. We will check like if the previous cell again it is reachable, and if it is reachable, then I'm checking the value of the grid. If it is there, then just I'm adding the base and I'm checking the maximum. I encountered one maximum value and then I'm taking the maximum value. And same from the left side, I'm checking and finally I'm putting that is in the maximum value. Nothing much, it's a simple logic. Like you have to understand this approach, like how I can reach for any particular index, what are the possible values, and can I reach it or not. That is the first point that we are missing in the brute force solution. We are doing blindly every path, and in the optimization path, just you have to encounter this, like to store the pre-computed values, and you have to use them. And going further, it's just nothing like I'm just adding the then finally base. And if the base like maximum sum of the minus like bottom right cell, it means the destination cell itself, it is not reachable. If it is not reachable, then I just simply adding like 0, 0. There is no possible solution. And if it is there, then I'm just adding the maximum sum and finally I'm returning the list. So it is also like it is a working solution, of course. But the point is, you have to understood like how this approach is valuable. So you have to, if you not understand, please reiterate it. And if you have any questions, please comment on it, and please comment it. I will try to address that. And if you like or learn something new, please like and subscribe my channel.